Hi everyone and welcome back to the course. As I promised, in this video we will talk about how to use DevSecOps with AWS, Azure and Google Cloud. So let's get started. So in the previous videos we discussed the DevSecOps principles and how the pipeline is built with embedded security. So in this video we'll look at the best practices for applying DevSecOps in the major public cloud platforms such as AWS, Azure, and Google Cloud. So let's first talk about how we can implement DevSecOps on AWS code pipeline. So before starting to explain the DevSecOps in AWS, we need to understand that deployments in AWS should be based on the principles of the Cloud Adoption Framework. The framework covers specific security tasks and responsibilities grouped into 4 categories. And those are prevention, detection, correlation, and direction. So as you can see on the figure in front of you, AWS offers native solutions to provide controls for managing security postures for CI/CD pipelines. So here on the pipeline, you can see the different steps organized. So an important artifact here are the security groups, as you can see. Those could be bins where the security posture of all of the components that are developed and deployed in the pipeline are defined. It contains templates and policies that have to be applied to those components. So you can see that the code is going from the Git repository to S3 bucket, which basically is something like a drive in which we can place any type of data, mainly used for images. Then we put the code to the code pipeline and then it goes to the different security groups. So the static code analysis are performed on the code that is pulled from the S3 bucket right here. So once we pull the code from the S3 bucket, we're creating a stack of containers that contains virtual private cloud in AWS to run tests. So those tests are used to run the code on the stack and validate the build. AWS calls this stack validation, and then certain Lambda functions validate the stack against each and every security group. Okay, so everything that has to be defined into the security, we need to meet in those security groups. So this is the second station, which is a test. And so after that, we're running into the production. So in the production, after the successful stack is validated, a Lambda function is triggered to prepare the stack for production using the CloudFormation templates. So examples of items that are checked against security groups can be validated using access and permissions, access controls to the S3 bucket, and policies to create instances using, for example, EC2 compute resources. So Microsoft Azure actually uses a different approach from AWS when implementing DevSecOps. This solution leverages the scan possibilities of GitHub. It also leverages the features of the Azure Kubernetes services next to the Azure pipelines. And you can see it right here. So here in this diagram, you can see high-level architecture for a security embedded CI/CD pipeline using GitHub and Azure services. You can also see certain numbers in the diagram, like right here is 1, then 2, 3, and 4. Okay, so those numbers represent the order in which each step is taken when working on the cloud. As soon as the containers are pushed to the Azure Cloud repository, they are scanned against the policies that are stored in the Azure policies, right here that you can see. So first we push the containers, and after that, in the next step, we're validating against the Azure policy. So after that, the appropriate security keys right here are fetched to authenticate the containers to the Azure Kubernetes service. Only when all checks have passed successfully, the code will be then pushed to the application gateway. So if we look a little bit more in detail, we can see that the Azure cloud is quite secure, and the solution starts with the code analysis in GitHub, which involves using code QL to detect vulnerabilities in the source code and dependencies respectively. Then once the code has been validated, it's packed to Docker container and deployed to a test environment using the Azure DevSpaces. This is done through the Azure pipelines. So the Azure DevSpaces will build an isolated test environment for the Azure Kubernetes service. Then when we scan our code, containers are stored into the Azure Container Registry where they're scanned against the security protocols. To do this, Azure uses the Azure Security Center, which is a huge library that holds all security policies for the environments enrolled in Azure. And finally, when we reach our production stage, the scanned containers are pushed to Kubernetes cluster using the Azure Kubernetes service. Azure policies are used to validate the compliance of the provisioned clusters and containers. So just like the AWS, Azure uses several different solutions to provide end-to-end solution that embeds security roles, policies, and postures throughout the whole CI/CD process. However, all those solutions start with repository where those security guidelines and guidances are stored and managed. Security groups that are managed through AWS Security Hub are located into the Azure Security Center. So let's see how the DevSecOps are actually implemented on Google Cloud. Well, this is normally done using the Anthos and the JFrog methodologies. So the Google Cloud involves interesting best practice solutions for implementing the DevSecOps pipelines using JFrog. So it doesn't only provide cloud native pipeline, but also a solution for developing and deploying hybrid environments using the Google Cloud and the on-permission systems. This is quite interesting for enterprises since a lot of enterprises will not move their IT systems completely to public clouds. Most enterprises are expected to move more and more systems to the cloud, but some of their system will remain private in the stack. So CI/CD pipelines that are suitable for both cloud and on-permission solutions are quite favorable, and with Kubernetes they're quite easy to set up. So you can see the architecture here in front of you using JFrog right here and Kubernetes. So there are two major solutions, and the Google Cloud advocates for using JFrog Artifactory and JFrog X-Ray. So JFrog Artifactory takes care of storing artifacts that are used when building applications. So we already saw how pipeline starts by pulling code from the source repositories. Developers need to be able to rely on the tooling that stores and other artifacts, code building blocks, in a comprehensive and safe way so that software delivery to the pipelines can be automated. And I've been actually using and still use Artifactory for my current projects in the company I work for. The JFrog X-Ray scans the artifacts and the code building blocks through Artifactory against known vulnerabilities and license compliance. X-Ray uses the shift left mentality by already scanning the source artifacts. And you can see the complete diagram right here in front of you. So JFrog is basically using X-Ray as the main security solution that is embedded to the pipeline. Builds are taken and then pushed to the production using the Kubernetes Google Cloud Platform and on a platform called Anthos. So Anthos ensures a consistent layer of deploying and managing Kubernetes clusters across the native cloud of the Google Kubernetes engine and on permissions. This solution is only feasible with Google Cloud, but can be also used on the VMware stacks as well as on the AWS as well. So this is how DevSecOps can be implemented on all of the major cloud service providers. Thanks for watching this video, and in the next one, we will talk about how you can plan your development and about the main cybersecurity frameworks. Thanks for watching.